Welcome to part 4 of Competency 6. In this video, we will work with direct and inverse variations. Okay, let's talk about direct variation first. This would mean that y varies directly with x. Well, this means that when one goes up, the other one goes up, and when one goes down, the other one goes down. So these values increase and decrease together. Now, if we're going to talk about indirect or inverse variation, well, they will increase and decrease opposite. If one goes up, the other one goes down. If one goes down, the other one goes up. So they're just not going to do anything together. And the only way for us to really understand that fully or remember it completely, let's do some example problems. Let's look at number 1. Okay, I'll go up here and give us some room. Okay, so if y varies directly with x, okay, and y equals 20 when 8 x equals 8, find the equation that relates to x and y. Okay, so what you need to remember for this is that you're going to have y equals k is some constant, okay? And then we have x. So let's think about this. If one goes up, the other one has to, okay? So let's take a look at what this would mean, okay? So we have 20 here, okay? And then we don't know what k is, but we're about to figure it out. And then we have 8, okay? Because 8 is x. Right? So, how do we discover what k is? Well, that's by dividing both sides by 8. So, we have that k equals 20 over 8. Okay. Well, now that we know what k is, we can just, let's pop that in the calculator and then just substitute it back into the original equation. Okay. All right. So, but this is what we need to see here. Let me get out my highlighter. This equation shows the direct variation, right? So there's our fraction and 20 over the 8. There we go. Oh, but looks like I don't see anything particularly good here. Hang on a second. A is not good, B is not good. Let's just get rid of them right out of the box. Okay, well, let's push our toggle button 2.5. So that has to be D, and C was showing the reciprocal here, so that's not going to work. Okay, all right, so now that we understand that, okay, or we have reviewed it, let's go to number 2. If y varies indirectly with x and y equals 20 when x equals 8, find the equation that relates to x and y. Okay, indirectly. Okay, so what are we honestly looking for here? Well, there's a couple ways to think of this, but let's go ahead and do the time-honored y equals k over x. Okay, so how could we view that? A lot of ways that we could think of it, but one way that helps me keep it straight is by looking at the k over the x. The larger x gets, the larger x gets, the smaller the whole value on the right hand side becomes. Well, that whole right side, as here, let me show you here. As x goes up, the entire value here goes down. And the best way to initially look at that is to think of this. 1 over 2 is a half, right? Well, let's look at another one. Well, 1 over, let's go to 4. Well, what is that? It's 1/4. Well, that we can put it in decimal value and see that the entire value goes down as that denominator increases. Actually, that's the rule that tells you that, well, it's going to get closer and closer to zero, further away from one. Okay. Well, that's just one way to think of it initially. Okay. Now, so let's go ahead and find this K. All right. So we have 20 over here. We have K here. Over what? Over the 8. Well, how do we deal with this? Well, that means we have to multiply both sides by the 8. So then K will equal, well, 8 times 20. And I know that you probably already see that, but when you're taking a test, put everything in the calculator, please. It just saves on the, here, let me write this better. It just saves on the brain power. So you've got energy for later when you continue your test. Okay, so that gives us 160. Now we look for the setup that works for us and plug the 160 back in. Huh. Well, we know, let's see here. I don't like A because these are, switch their positions. So that's not good. Well, obviously B is not going to work. So now let's look at C and D. Well, the correct setup is C, and D would give me the direct variation, not the indirect variation. So that's not going to help me out. So it is option C. All right, let's move on to number 3. Number 3. We are driving from Bernie to San Antonio at an average speed of 50 miles per hour and arrive in San Antonio after 44 minutes. If the speed varies with varies inversely with time to the nearest minute, about how many minutes would this trip take you if you were traveling at 40 miles per hour? Okay. All right. I'm going to write a few things to kind of help your brain wrap around this. They said inversely. Well, there is a mild trick to this, okay? First, we're going to look at our miles per hour. And it said that this, okay, varies inversely with our time. It says right there, time, okay? So let's put our T here. Okay, the first miles per hour we had were 50. And then the next miles per hour we had were 40. And it says that it varies inversely. So, what do we write? Inversely means that we go up here and look at 50 and the time was, oops, 44.4 minutes. So this tells me that I need to write that as my denominator of 44.4. And then my x would be above that. And okay, you may be saying, well, smarty pants, how do you know this is going to work? Well, let me show you. All right, I'm going to draw a line here and change colors. And I'll write a few things out for you, and you can stop the video, or when you're done, go back and prove this to yourself. Play around the numbers and you're going to see that I'm on to something, okay? So I calculated the actual miles from Bernie to San Antonio, and I know this because I've driven it. Actually, I drive it very often. And I know that I have, okay, this is my distance in miles, and I know that D equals RT. DRT is an equation that we start dealing with in 7th grade. Distance equals rate times time. Okay, so what is my time? Well, I know first that I have 50 miles per hour. That's my speed. And I know that I had a time of 44.4 minutes, but guys, that's out of an hour. Remember, it's miles per hour. So you've got this conversion issue here. Don't forget that. And then you have this little issue, and I promise you this works out. You also have the 40, right? And then, however long it takes you, it has to be out of 60. Okay? When you start manipulating that, don't worry about the 37 miles. Start playing around with the other two expressions and make it equal to x. Like, just look at what I have and look at how it would turn around. Play around with it, and you'll see that I'm good to go. Okay. That we can do this. Okay. It will work. Okay. Now, so what do we put in our calculator? Well, if you look at it, and yes, I am kind of skipping steps. This is what we have. We have x equals, set up your fraction, and it's going to be 50 times 44.4 all divided by 40. Okay? Now, don't forget, it says to the nearest minute. And looking from our ABCD options, I do believe we will have to do some rounding. Okay? All right, so let's set our fraction up. And I see 50 times 44.4, arrow down, dividing by 40, double check, push enter. Yes, and because it's a half and it wants us to round, that means we need to go up because remember rounding? If it's 5, if the decimal is 5 and up, we go up. So that leaves us with option D. Okay? All right, let's look at number 4. The cost of moving, I'm sorry, the cost of moving. The cost of mowing a lawn varies directly as the lawn's area increases. Well, that makes sense. If you've got more lawn, they're going to charge you more to mow a large lawn versus a small lawn. It just makes sense. Suppose that the cost of mowing an area of 30 square feet is $75. What is the cost of mowing an area of 50 square feet? Okay, now that's direct. So that's not as tough to deal with. So if we look at the area, okay, and we say that that area is going to varies directly. So then we can write this. Look at our areas. Well, we had 30, then 50, 30 over the 50, and then 30 area to cost was what we were dealing with. Well, we know 30 equals $75. Now let me show you this. If it's going to be a direct variation, the values should be across from each other, okay? And yes, we're setting up a proportion, but if you go back, do the calculations like what I showed you in number 3, take it all the long way around and you'll discover this works, okay? Now we're looking for x, okay? So we know precisely what to put into the calculator, okay? I have x equals 75 times 50 all divided by the 30. So we come over here to our calculator. We say 75 times the 50, go down, and 30, and enter $125, which is option C, which makes sense, okay? All right, now let's look at number 5, okay? Yes, all right. You want to have a Super Bowl party. Each of your friends has agreed to share the cost equally. If 60 people attend, each person will pay $15. The number of people attending varies inversely with the cost per person. What will the cost per person be if only 50 people attend? Okay, so you're going to have people, I'm just going to say P, and then you need cost. Okay, and I got my equal. Let's set this up. Okay, so we're saying 60 people, and then what if it's 50? Now remember, if it's inversely, then the cost has to go, let's say, across or something. So it has to be inverted situation. Okay, so then we know for 60 it's 15. Then our x would go above that. So what do we put into the calculator? Okay, well, that would mean that we need to put in x would equal 60 times the 15 all divided by the 50. We should get a decent value. Okay, so set up your fraction and then 60 times the 15. Oh, nope, 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 nope. Sorry, I pressed enter. Wait, let's clear. Ah, there, it just goes back for us. Awesome. And let's put in the 50. You saw what happened to me, right? I pushed enter too soon, but then when I went back and pushed clear, it popped me back to where I was, where I could type it in. Now, let's push enter. And option D is correct. Okay, which would make sense. So if only 50 people attended, then you still have the same total cost. Just like above, when we had, you know, actually number 3, you had 37 miles. The distance didn't change, but the people that were going to take on the cost change. So naturally, they would have to pay more money the more people that came, the less that was at your disposal. There'd be less food, less drink. There wouldn't be anything left. Let's just say there's no leftovers to take home, whatever. So you wouldn't pay as much. Okay. You're going to pay more because you have to absorb that cost. Okay. All right, let's look at number 6. Number 6, the miles a particular vehicle travels varies directly with the number of gallons of gas the vehicle uses. So the further you go, the more gas you use. Makes sense. Okay. When the vehicle travels 35 miles, it uses 1.8 gallons of gas. How many miles could this vehicle travel using 3.2 gallons of gas? Okay, the key here is it's going to vary directly, okay? Directly with what? Gallons. Okay, number of gallons. So you're going to have the number of gallons. So looks like, ah, the number of gallons versus the miles. Okay, we're on gallons. Okay, I'm going to say GL, and then miles over here. We need our equal. Set this guy up, and they're going to be direct. So it'll go across like this. Okay, so gallons, first they say for 35 miles, we have 1.8. So I want my 1.8 gallons over here to my 35 miles. Those go together. Now I come down and they're saying, well, what if it was 3.2? Well, now I know where to put my x, okay? All right, now what do I put in the calculator? Well, that's not hard to figure out. X equals, so then I have 3.2. Let's get rid of that. 3.2 times the 35 miles all divided by the 1.8. Let's go over here in our calculator. All right, 3.2 times 35, go down, divide that all by 1.8. And looks like we have a bit of rounding. Yeah, it's pretty obvious which one it is. It's option A. Okay. I mean, they also could have uh we could have said this to get an exact 62.2 with that repeating too. would be a really good value, but we have to go with the answers they gave us, okay? All right, now let's look at 7. Let's go up here. Okay. A college's tuition, no, a college's tuition is charged per student, okay, and varies inversely as the number of students. So that means with the number of students as they increase. Okay, we'll look at this in a second. This year, the student enrollment is 5,200 and the tuition is $800 per student. The university forecasts that the college enrollment for next year will be 5,500. To the nearest dollar, what will the tuition per 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 student next year be? Oh, that was a little clumsy. Doesn't matter. Okay, so we have number of students, and then we have the big price. Okay, so we can go ahead and set up, and let's look at number of students. So they're saying if you have 5,200, then you have $800. Okay, but remember, we have to be inverse. So we still have that. We start out at 5,200, but then we go to 5,500. Okay. Uh-oh. Well, I'm not writing this correctly because it said inversely, and I just said that a minute ago. So I can't write the 800 across. I have to do my little inverse. I can't go straight. I have to go inversely. Okay, not directly, inversely. Okay, now that makes more sense. Okay, all right, now I know that my x would go above the 800. All right, now that I've corrected everything and it looks copacetic, let's show what we're going to stick in the calculator. Okay, I say x equals, okay, so we have 5,200 times the 800 over the 5500. Now let's put that in the calculator and see if we come out okay. Okay, so there's our fraction, 5200 times the 800, go down, and 5500. Go back, make sure we look good. All right, let's push enter. Oh, looks like we need our toggle button. There we go. Now we have something we can work with. Well, looks like we need to round. Okay, it says to the nearest dollar. Okay, and because 3 is less than 5, we stay with 6. So that gives us option C. Okay, and if you really look at it, there's no other good way to round. Kind of like, I know it says to the nearest dollar, but you're kind of locked into C. Okay, all right, let's look at number 8. For your graduation party, you know that you need 200 pounds of mashed potatoes, which can feed 300 people. If you order 125 pounds of mashed potatoes, how many people will this amount feed if each person needs an equal portion? Oh, goodness. Okay. All right. Well, let's look. We're talking about pounds, which I'm going to use LBS. Pounds of mashed potatoes. And then I'm going to say the number of people. Okay. All right. Well, let me see here. And how did it, uh, oh, they're not telling us. Goodness. Okay. We have to make some executive decisions here. Are they inverse or do they vary inversely or directly? Well, my thought is it's direct. If the amount of people increases, your need for mashed potatoes increases. If your amount of people decrease, the amount of mashed potatoes you need decreases. So I say they're direct, a direct variation. I mean, sometimes they don't tell you this. It just stands to reason and it's logical, makes sense. Okay, so if it's directly, then we know that we're going to have this situation. Okay, all right. So, number of people. Well, they're saying you had 300 the first go round. We knew about that. And for those 300, we had 200 pounds. Okay. And then they said, okay, what if we went down to 125 pounds? So come over here and write the 125. This means the X goes here. And for the calculator, this would imply that we need to put this in. We need 300 times the 125, all divided by the 200. Okay, well, let's give it a go and see what happens. All right, let's see. There's our fraction, and 300 times the 125, arrow down, 200, push enter. Oh, we need our toggle, and lo and behold, but be careful. Now, we had to, or rather, look at the inference. Was it direct or indirect? Now there's another thing that's implied, and it is implied all over our paper if you haven't already figured this out. We are talking about people, okay? And our value says 185 point, 87, 187.5 people. You cannot have a half a person. I tell my, especially seventh graders, this little fact kind of eludes them. No, you can't put half a kid on a bus. So we aren't feeding half a person. Okay, I know that they can have all kinds of rationales for that. So the logical thing to do is round up to the nearest person. Always think about that. It's putting them on the bus to the nearest person, feeding them something, paying for something. Well, the restaurant doesn't say, "Oh, don't worry about it. Pay for half a person." No, we don't do that. So you got to round up. So the only logical thing would be 87 or round down. In this case, the only answer they gave us was to round down. It had to be the nearest person. So in this situation, the question was, let's look at it. How many people will this feed if okay, equal portions? Okay, well, if we have a half, that's not equal. So that's just set to the side, and it would have to be 187, which, if you think about it, it makes sense. Okay. All right. This is the last question in this video. I appreciate you all uh, watching all the way to the end. And thank you so much for those of you who have subscribed. You are phenomenal. Greatly appreciated. And sharing and liking us, that is amazing. Thank you so much, everybody. And shout out to anybody who's actually passed their test recently. I did get some notifications. Congratulations, guys. Happy testing.